So 2021 specimen paper. This paper would have been made in 2018. This is when it had a change in the syllabus. So number 1A, part 1, determine the remainder when f of x is divided by x plus 1. Before I start, actually no, I'll go give you the advice in a separate video, right? So f of x divided by x plus 1 is equal to f of 1 colon 2 into 1, actually no, equal to 2 into 1 cubed plus b into 1 squared plus 2 into 1 plus 5. And this is equal to 2 plus 2 is 4. 4 plus 5 is 9. So I get 9 plus b. So this is the remainder when f of x is divided by x plus 1. Now I used the remainder theorem here, so I'll quote the remainder theorem. If any polynomial f of x is divided by x minus a, the remainder is f of a. That's the remainder theorem. The factor theorem is if f of a is equal to 0, x minus a is a factor of f of x. Part 2. If the remainder when f of x is divided by x minus 2 is equal to the remainder in a part 1, calculate the value of b. So f of x divided by x minus 2 is f of 2. Oh, x plus 1 is going to be f of minus 1. So minus 1 cubed, minus 1, minus 1. My apologies. So it's going to be minus 2. Minus 2 is minus 4. Minus 4 plus 5 is 1. So I'll get 1 plus b. So f of 2 is equal to 2 into 2 cubed plus b into 2 squared plus 2 into 2 plus 5. This is equal to 2 to 12 is 2 to the power 4. Just jump on your calculator and work it out, right? I'll get 2 to the power 4 plus 2 to the 4 plus 5. 25. So I'll get 25 plus 4b. So now they say both remainders are equal. So I will let 1 plus b is equal to 25 plus 4b. Move the 4, I'll get b minus 4b is 25 minus 1 minus 3b is equal to 24 and b is equal to minus 8. Bam shot, we're good to go. Right? Right, I now see all your messages there. Part B, the function g of x is equal to that. Has real roots when b squared minus 4ac is greater than 0. Determine the range of values of m. So I'm going to have, g of x is equal to x squared plus m minus 3x plus, I put in 2m minus 1 in a bracket. Now what they should have said m is a constant. They should have said that, but m is a constant. Okay, so this how g of x is equal to that is equal to 0. I just gonna put this. G of x is equal to this. A is 1, b is m minus 3, and c is 2m minus 1. b squared minus 4ac is greater than or equal to 0, which means b squared m minus 3 squared minus 4ac is greater than or equal to 0. So I'm going to let this be equal to 0. So I got square the brackets one time. M squared minus 6m plus 9. Take away 4 2s are 8m. 4 by minus 4 by minus 1 is plus 4. Equal to 0. I put it equal to solve. M squared minus 6 minus 8 is minus 14m. Plus 9 plus 4 is plus 13. Is equal to 0. Minus 1 and minus 13. M squared minus m minus 13m plus 13 is equal to 0. M into m minus 1 minus 13 into m minus 1 is equal to 0. M minus 1 into m minus 13 is equal to 0. I get m is 1 or m is 13. My job was to calculate the roots. When I calculate the roots, I'm going to draw my quadratic now. Before I sort out to simplify and solve, I'm looking to see what kind of quadratic it's going to be. It's a positive m squared, which means I'm going to get a smiley face. My roots are 1 and 13. And I would like to know where this graph is greater than 0. The graph is greater than 0 above my horizontal line, which represents my x-axis. So it's going to be here and here. So my range of values will be x is such that x is less than or equal to 1 union x is such that x is more than or equal to 13. So just reinforcing the fact that we have this more than or less than or equal to and more than or equal to because the sign in the question has an equal to attached to it. Express this in the form a into x plus b squared plus c. So we're going to have 3x squared plus 12x minus 18. You can actually complete the square in one beautiful line. So the beautiful line is, I will factorize the x terms. So I'll have 3 open brackets x squared plus 4x plus, I am adding in a new thing here. I am adding in half the coefficient of x, which is 2, and I put in a square on top of it. Continuing the quadratic, minus 18, but I added in 2 squared, but I really added in 3 by 2 squared, so I had a takeaway. 3 into 2 squared. Yes, it have plenty ways in which you all can solve, complete a square. Whichever way you want to, organize yourself. Minus 18 minus 3 into 2 squared. I get minus 30. But your statement is of the form a into x plus b squared plus c, where a is 3, b is 2, and c is negative 30. Now we saw a custom with a into x plus h squared plus k. And because we saw a custom, I'm going to write it down. A into x plus h squared plus k. We are custom with this version. This could be a, this could be h, and this could be k. So I'm doing that in the to help me with the next two parts. State the minimum value of h of x. So the minimum value of h of x occurs at k, at h of x is equal to k. But we don't have k, we have c. So instead of k, I'll write c, which is equal to negative 30. Determine the value of x for which h of x is a minimum. The value of x for which h of x is a minimum occurs at minus x is equal to minus h. But we don't have h, we have b. So instead of minus h, I have minus b, which is equal to minus 2. All right, and that's it for number 1. Number 2, Given that this is that and that is that, find the value of a. So the only problem I'm going to have here is not all the bases are going to be the same thing, but a small thing. I'm not going to rewrite the question. However, I'm going to recall the laws of logs I am anticipating to use. Log of a, log of m to base b, take away. Log of n to base b. The laws of logs, they work in both directions. That's log of m divided by n to base b. And I say the next law, log of a to base a is equal to 1. So I'll utilize the first recall. So I'm going to have log of 4 minus root 8 divided by 2 minus root a to base 2 is equal to 1. Now what I could do, I could replace 1 with log 2 to base 2. So I'll have log of 4 minus root 8 divided by 2 minus root a to base 2 is log 2 to base 2. Only when I have 1 log on the left is equal to 1 log on the right and the bases are the same, can I say remove log to base 2. So I'm going to have 4 minus root 8 divided by 2 minus root a is equal to 2. So we could do a couple things here. The easiest thing I see to do here is not to rationalize. I'm going to cross multiply. 4 minus root 8 is equal to 2 into 2 minus root a. And I'm going to rearrange. I wouldn't divide by 2, I will expand. 4 minus root 8 is equal to 4 minus 2 root a. Move the minus 2 root a, I get 2 root a is equal to 4, move the minus 4 plus root 8. So I'll get 2 root a is equal to root 8. It have a number of ways we can do this. If you're not really comfortable, root a is equal to root 8 divided by 2. You could go on a calculator. A going on b, root 8 divided by 2 squared. I'm making sense to all, right? Root 8 is that divided by 2 is that squared is 2. So I get a is 2. Another way we could have done this is by breaking down root 8 as root 2 root 4. Root 4 is 2, so I'll get 2 root 2 over 2 is equal to root a. Bam, bam. Root a is root 2. A is 2. Get the exact same result. So a very, very similar question to the discriminant question in part B. So I'm just going to put the working underneath in this case, right? Just know this is 4 marks. All right, find a set of values for which this. So you will get a mark 3 minus x divided by 2x plus 1 is less than 0. You'll get a mark for multiplying by 2x plus 1 all squared. I'll get 3 minus x into 2x plus 1 is less than 0. But I'm going to let equal to 0 because I'm going to solve. I'll get 3 minus x is equal to 0. And I'll get x is equal to 3. Or I'll get 2x plus 1 is equal to 0. I'll get x is minus a half. So these are my roots. I have a, from this, when I expand out this, watch it good, my minus x by 2x is minus 2x squared. So So I'm looking to see what kind of curve it is. This is going to be a maximum curve. This is going to be minus a half. This is going to be 3. I want to know where the graph is less than 0. It's less than 0 here and here. So my solutions going to be the disjoint set of values again. X is such that x is less than minus a half. The reason I didn't put the equal to over here is because my question didn't have the equal to on it. Union x is such that x is greater than 3. Easy 5 marks. John deposits 5,000 at 12% per annum into his bank account. The bank compounded interest is represented by the geometric progression. Amount is p into 1 plus r over 100 raised to the power of t, where t is a positive integer. Determine the number of years it would take for John's money to at least double. So at least double means double or more. So I want to see when his money will be more than $10,000. So when I want to know when the amount is going to be more than $10,000. So I'm going to say amount going to be 10,000. I'll go put the 5,000 by 2, which is the $10,000. My principal, 5,000. My rate is 12%. And my time is unknown. So we had to figure out what time is. So I've seen our logs coming in to the play here, most likely. So I'm going to let 10,000 be equal to 5,000 into 1 plus 15 over 100 raised to the power of t. Divide both sides by 5,000. I'll go get 2 is equal to 1 plus 0.15, which is 1.15 raised to the power of t. Bam, bam. Yeah. So I will... Sorry. Thank you very much. 1.12. So I will take LG on both sides. I'll get log 2 is equal to log 1.12 to the power t. I'll recall a law of logs that allows me to bring the t as a coefficient, which is going to be log of a to the power c to base b. The laws work both ways. It's c log a to base b. So log 2 is t log 1.12. Log 2 divided by log 1.12 is equal to t. So let me see what approximation we get for t here. Log 2 divided by log 1.12. I get 6.12 years. So t is equal to 6.12 years. Now, in 6.12 years approximately, the money is going to double. They want to know the number of years it will take for his money to at least double. I don't want to give years as a decimal, so I will say t for the money to at least double, or it takes 7 years for the money to at least double. And that's it for number 2. Number 3, a circle has center and a point is on the circumference. Determine the equation of the circle expressed in the form that. All right. So if the circle has center minus 3 minus 4, they want us to express the circle in the form. So what I could do, it have plenty ways and plenty equations to represent the equation of a circle. One equation that I use a lot of the times is going to be either x minus a squared plus y minus b squared is equal to r squared. This one is very applicable in this case. It seems to be the easiest one to use. So x minus 3 squared, let me recall. X minus a squared plus y minus b squared is equal to r squared. AB is the center, and r is the radius. So if I have the center as minus 3 minus 4, so I have x minus 3, x plus 3, x minus minus 3 squared plus y minus minus 4 squared is equal to r squared. They wanted to express in this form, right? So what we're going to do here, they say that our 5, 2 is a point on the circumference. So what I could say is, here was the scene. This here becomes x plus 3 squared plus y plus 4 squared is r squared. So at 5, 2, the equation turns into x is 5, 5 plus 3 squared plus y is 2, 2 plus 4 squared is r squared. So let me work out this on the left hand side. Now again, it has more than one way to do this type of question. We'll do an alternative way after. 5 and 3 is 8, 8 squared is 64, and 4 and 2 is 6, 6 squared is 36, looking like 100. So 100 is equal to r squared, and r is equal to 10. So my radius is 10. So watch what I could do now. Since my radius is 10, I can now say the equation is going to be x plus 3 squared plus y plus 4 squared is equal to 10 squared. Now I could go ahead and expand it out. X squared plus 6x plus 9 plus y squared plus 8y plus 16 is equal to 100. X squared plus y squared had to go first, no scene. Then the ax, then the by plus 6x plus 8y. Then the constant. The constant will be 9 plus 16, which looking like 25. And when I bring the 100 across, it becomes minus. So I'll go put plus 9 plus 16 minus 100 is equal to 0. Then I'll go have my x squared plus y squared plus 6x plus 8y. 75, right? Let me just double check. Nothing wrong in double checking. 9 plus 16 minus 100 is minus 75. Good. Minus 75 is equal to 0 is of the form x squared plus y squared plus ax plus by plus c is equal to 0. Determine the equation of the tangent to the circle at the point P, 5, 2, 4 marks. So let the tangent at P be, I like to call it L1. You could call it anything you want. I'm gonna let the center, let O be the center, which is going to be, no, C is center. Now, if I draw this, right, the best way to visualize these kinds of questions is to draw it. So we have the center. It don't have to be accurate. I have the center, I have a point. This is P. I want to grade the equation of this tangent L1 at P. Well, if I get a gradient of the radius, which is CP, I can now go and use my laws of circles along with my laws of gradients to get a gradient of L1 and then calculate the equation of L1 using the point P. So I'm going to say the gradient of CP is y2 minus y1 over x2 minus x1. So on the paper itself, you can say let C be x1, y1, and let P be x2, y2. So y2 minus y1 over x2 minus x1. There's 2 plus 4 is 6. 5 and 3 is 8. 6 over 8 is 3/4. That's a gradient of CP. The gradient of L1 is equal to minus 4 over 3, negative reciprocal, and I give them the reason why. You need to say the product of gradient of perpendicular lines is equal to minus 1. I don't want to see product of lines is minus 1. I don't want to see perpendicular lines is equal to minus 1. That don't make sense. It's the product of the gradients of the perpendicular lines is minus 1. The equation of L2 using P, which is 5, 2. This now becomes my x1 and my y1. Is given by equation y minus y1 is m into x minus x1. Y minus 2 is minus 4 over 3 into x minus 5. Did they want it in any particular form? They didn't, but we always like to put it in the form y is mx plus c plus 20 over 3 plus 2. 2 is the same thing as what? 6 over 3. So this becomes 26 over 3. Y is minus 4 over 3x plus 26 over 3. You see, is of the form y is mx plus c, where m is the gradient, which is minus 4 over 3, and c is my y-intercept, which is equal to 26 over 3. If you want to double check and make assurance, 20 over 3 plus 2, plus 2 is 26 over 3. Good. All right, so next question. Vectors. The position vector of 2 points A and B relative to a fixed origin O are A and B respectively. Okay. The point P lies on OA such that OP is PA. Determine the vector PB. Now, our diagram will help us visualize this a little better. It don't have to be correct. It don't have to be perfect. All right. So let me just see. 2 points A and B relative to a fixed origin O. Now, at least try to draw it a little bit accurate. It don't have to be a perfect diagram, right? So this is my origin O. A is minus 4, 6. So minus 4, 6 is over here. So this is A. So this is my vector O to A, which is symbolized as little a. Minus 3, minus 4, looking somewhere down here. And this could be my vector B. And this is little b. The point P lies on OA such that OP is PA. So P will be in the middle. Determine the vector BP. So I want this vector BP. No C. So BP is equal to B something plus something P. And the only letter I have common in B and P is O. So BO plus OP. BO is negative OB plus OP going to be a half of OA. Minus OB is going to be minus little b plus 1/2 little a. I know what little b is. Little b is minus 3 minus 4. So this is minus 3 minus 4 plus 1/2 into a, which is minus 4, 6. This is going to be 3 plus negative 2, or 3 minus 2. So let me write it down now. So this is going to be 3 minus 1/2 of minus 4 is 2. And minus 4 is plus 4 plus 3. And I'm going to get 1, 7. Determine in its simplest form the magnitude of the vector BP. So the modulus of BP is equal to the square root of 1 squared plus 7 squared. You can mental this one is the square root of 50. Simplify down. This is the square root of 25 by the square root of 2, which is 5 root 2 units. Given that tan of pi on 4 is equal to 1 and tan of pi on 6 is equal to root 3 on 3, without the use of a calculator, evaluate tan pi on 12 in simplest surd form. So how am I getting pi on 12? By using pi on 4 and pi on 6. So let me try. Pi on 4 plus pi on 6. Let me see if that's going to work. It have the shortcut to the LCM. The 6 pi plus 4 pi all over 24. This is going to be 10 pi over 24. This is not equal to pi on 12 at all. So let me try to take away the two numbers now. Pi on 4 take away pi on 6. 6 pi minus 4 pi all over 24. This is 2 pi over 24. Hey, we get the pi on 12. Now, if I had tried pi on 6 minus pi on 4, I'm going to end up with minus pi on 12. And well, from there, you're supposed to know to just switch around the two numbers. So now I can see tan of pi on 12 is equal to tan of pi on 4 minus pi on 6. I'm going to recall my compound angle formula for tan. Tan of A plus B is equal to tan A plus tan B over 1 minus tan A tan B. So tan of pi on 4 minus pi on 6. I recall the wrong one. All I had to do is switch the signs, right? So instead of tan of A plus B, I'll have tan of A minus B. And I'll have A minus B on top and plus below. This is tan pi on 4 minus tan pi on 6 divided by 1 plus tan pi on 4 tan pi on 6. From the information, tan pi on 4 is 1 minus root 3 on 3. So notice what I do in here. I'm putting a big division sign. 1 plus 1 multiplied by root 3 over 3. I'll simplify my numerator. This is 3 minus root 3 divided by 3. I'll simplify my denominator, but I'll put in the division sign. 3 plus root 3 over 3. This is 3 minus root 3 over 3 multiplied by 3 over 3 plus root 3. The 3's cancel. This is 3 minus root 3 over 3 plus root 3. Now, some of you all might want to go ahead and rationalize this. I don't see the need because this is in simplest surd form. For 6 marks, I think this is enough for 6 marks. If the question wanted you to go further, they would have said they would have given you a particular form to express your answer in. So don't fight up and go and rationalize. You could leave it like this. Alright, and that's it for number 3. Differentiate 2x sine 2x with respect to x. So first, let y be 2x sine 2x. And one time is of the form y is equal to u by v, where u is 2x and du dx is 2. And v is sine 2x dv dx. The sine changes to cosine, and I must multiply by the differential of the angle, just 2. dy dx is equal to v du dx plus u dv dx. And this is my product rule. V, which is sine 2x, du dx, which is 2, plus u, which is 2x, by 2 cosine 2x. I'll get 2 sine 2x plus 4x cosine 2x. I mean, we could factorize all the 2, but it's neither here nor there for this one. A function given by y is equal to px squared plus qx plus r has a gradient of this and a stationary value of minus 2. Using principles of differentiation, find the values for the unknowns p, q, and r, and hence determine the function y. So y is equal to px squared plus qx plus r has a gradient 6x minus 6. So the gradient is dy dx is equal to 6x minus 6. That is the data. And at a stationary value, a stationary value is not a x value. The stationary point, if a stationary point is of the form a comma b, the stationary value will be b. So in this case here, the y value will be minus 2. So I'm going to calculate what dy dx is. dy dx is equal to 2px plus q. So I'm going to let 2px plus q be equal to 6x minus 6 stationary value but I will say there's a y value, has a gradient of 6x minus 6 at a stationary value of minus 2. Okay, watch. Rubbing this off here. We say at a stationary point, dy dx is equal to 0. So I'm going to let 6x minus 6 be equal to 0. 6x is equal to 6. X is equal to 1. So at x is 1 and y is minus 2, the stationary point exists because they gave us the y value here. So what I can do with this information, I can plug it into my function because these are points that will satisfy the function itself, right? So therefore, x is 1, y is minus 2. Minus 2 is equal to p into 1 squared plus q into 1 plus r. I have three variables here. So what I can do again, I can differentiate this. I can differentiate px squared plus qx plus r and set x is equal to 1. So let's do that instead. So dy dx is equal to 2px plus q. At x is equal to 1, that is my stationary value, right? Dy dx will be equal to 0. So I'm going to get 0 is equal to 2p into 1 plus q. I'm going to get 0 is equal to 2p plus q. So I have one equation involving p and q. I'll have another equation involving p, q, and r. Hmm. 6. If I let both equations be equal to each other, both dy dx be equal to each other, 2px plus q is equal to 6x minus 6. I get another equation involving p and q. Lord Father. Let me try it now. So now I can say, let both dy dx's be equal to each other. Let 6x minus 6 be equal to 2px plus q. At x is equal to 1, this is supposed to work. I'll get 0 on that side, and I'll get 2p plus q. Alright, I'll create this equation already. Q is equal to 2p. Find the values. I'm stumped. Alright, I will go come back for number 4. Yeah. If you integrate dy dx, you'll get back y, right? Let me try it. The integral of 6x minus 6 dx going to give me 6x squared over 2. This is going to be y, right? So dy dx is equal to 6x minus 6. If I integrate both sides with respect to x, I'll have the integral of dy dx with respect to x is the integral of 6x minus 6 with respect to x. Y is equal to 6x squared over 2. Take away 6x plus c, where c is a constant. Y is equal to 3x squared minus 6x plus c. At the point, what was the point? 1 minus 2. Get minus 2 is equal to 3 into 1 squared minus 6 into 1 plus c. We will get a value for c here. 3 take away 6 is minus 3. Move it across, I get plus 3. 3 minus 2 is 1 is equal to c. Therefore, y is equal to 3x squared minus 6x plus 1. Is of the form y is equal to px squared plus qx plus r, where p is equal to 3, q is minus 6, and r is 1. Now, one reason I would have been a bit reluctant to dive into integration here is because of this. Number 4 would test differentiation. And they said using principles of differentiation, which I used in the beginning, and then I used the principle of integration, which is, to me, that is no problem, because I did use principles of differentiation in the working. It come like this. I use principles of differentiation, and I use principles of addition. I use principles of subtraction. They never stopped me from using other principles. Similarly, they didn't restrict me from using another principle, which is the principle of integration. If they said, without using the principle of integration, go ahead, then this wouldn't be valid. So I use principles of differentiation, which are good to go. But I am a bit reluctant because number 5 will test our skills in integration. So that's why I'll be a bit reluctant. Nevertheless, we digress. We get the answer. It must have a way to do it using principles of differentiation, and I'll go figure it out. Alright, part C. Figure 1 shows the velocity time graph for 18 seconds of the journey of a car. The journey is made up of 4 sections: A to B, B to C, C to D, D to E. State what is happening between B and C. So if it's a velocity time graph, the gradient of a velocity time graph gives me the acceleration. So at B and C, I'll have a negative acceleration. So the car slowing down. So I can say that between B and C, the car is decelerating. Between C and D, plenty things happen in here. The car has no acceleration because it's a horizontal line, and also the car is at a constant velocity of 0 meters per second for 1, 2, 3 for 3 seconds. Now I could have said the car is at rest, right? But I want to be a little more fancy and show them that I know that straight line is constant velocity. Calculate the acceleration of the car between D and E. Between D and E, acceleration is going to be equal to the gradient. So acceleration is equal to the gradient of dE, which is equal to, you could go rise over run, or vertical distance over horizontal interval, vertical distance over horizontal interval, which is equal to, my vertical distance here is going to be this vertical distance here, which is 25 if the thing is drawn to scale. 25 divided by my horizontal interval, going to be this interval here, which stems from 12 to 18, which looking like 1, 2, 3, 4, 5, 6 meters per second. And I know it's going to be positive because the line is in this particular direction. Another way I gotta do it, get the coordinates of E, get the coordinates of D, and go ahead and calculate your gradient, y2 minus y1 over x2 minus x1. In which of the 4 sections does the car cover the greatest distance? Justify your answer by calculations. So the distance traveled for a velocity time graph is going to be the area underneath the graph. So the distance traveled is equal to the area under the graph. So what I'm going to do, I'm going to let my diagram be something. So they want to know which section, right? So I'm going to separate it, and I'll use a different color just to illustrate the separation, right? So I'll separate here as A1. This is A2. Me, I cover no distance here because he was stationary. And that's going to be A3. So area of A1 is going to be 4 by 20. So area of A1 is length by width, which is 4 by 20, which is 80 meters. Meters per second. Good. Area of A2 going to be 1, 2, 3, 4, 5, and 20. Area of A2 is 1/2 base by perpendicular height. This is the correct formula for the area of a triangle. It was 5 by 20. It was 5, right? I'm going to double check. 49 is 5, yep. Half of 100 is 50 meters. And then the area of A3, again, it's going to be 1/2 base by perpendicular height. And A3 could be 25 and 1, 2, 3, 4, 5, 6. Base is 6 by 25. And I'm going to get 75. Half of 6 is 3. Good. So A1 is where he covered the most distance, which is going to be the area of the, sorry, the, what did I say, the what? The section. So A to B, so you can say, therefore, during A to B, the car covered the most distance. And that's it for number 4. Number 5, find the following integrals giving your answer in its simplest form, 2x plus 1 cubed. All right, we can make a substitution here. The integral of 2x plus 1 all cubed dx. I can use the shortcut to integration here. It's just 2 marks, so we can use the shortcut, right? So what I'm going to do, I will treat the middle like a variable. So I'm going to get 2x plus 1 to the power 4 divided by 4. And along with the denominator, I must attach the differential of the brackets, which is 2 plus c, where c is a constant. This is going to be 2x plus 1 to the power 4 divided by 8 plus c. Next one, Ogid. All right, next one, we go ahead and separate it out. So we have the integral of 7x cubed minus 1 all over root x dx. This is equal to the integral of 7x cubed divided by root x, which is x to the half, take away 1 divided by root x, which is x to the half, dx. Using my laws of indices, this is going to be the integral of 7x to the power 3 take away a half, take away x to the power minus a half, dx. 3 minus a half, this is the integral. 3 take away a half is 2.5, which is 2.5 is what? 512. So I get integral of 7x to the power 5 over 2 take away x to the power minus a half dx. And here it's easy to go ahead and integrate it. I'm going to get 7x to the power 5 over 2 plus 1 is the same thing as 5 over 2 plus 2 over 2, which is 7 over 2, divided by 7 over 2. Take away x to the power minus a half plus 1 becomes a half, divided by a half, plus c. I'll put plus k, where k is a constant. Next line, I divide them by a fraction. I'll invert and multiply. So I'll be multiplying the numerator by 2 over 7. The 7s go cancel. And I'll get 2. And I'm fixing up the x to the 7 over 2. That's going to be the square root of x to the power 7. Take away 2 square root of x plus k. Figure 2 is a sketch of a graph y is equal to 2 sine x in the first quadrant. Using integration, determine the area under the graph in the first. Alright, cool. Easy peasy. So I'm going to let a be the integral between pi and 0 of 2 sine x dx. So a is equal to, when I differentiate cosine, I get negative sine. So when I integrate sine, I'll get negative cosine. So a is going to be minus 2 cos x evaluated between pi and 0. So a is equal to minus 2 cosine pi, take away minus 2 cosine of 0. So we're working in radians. So we could jump on the calculator and plug this in exactly as we see it. Make sure your calculator in radians. Open brackets, minus 2 cosine, open brackets, pi, close brackets, take away, open brackets, minus 2 cosine, open brackets, 0, close bracket, I get 4. 4 square units. Now some of them might want to go and count this, but don't count this, eh? I'm madness if you go and count this. Alright. A particle moves in a straight line so that its velocity k from a fixed point O is given by the equation k is equal to 2t cubed minus t, where t represents the time in seconds. When t is 3 seconds, the particle has a displacement w of 25 meters. Determine an expression for displacement w from O of the particle. Okay, so I'm going to make a little transition here. We know SVA, displacement, velocity, acceleration. When we're going down, we are differentiating. When we're going up, we are integrating. So if I have displacement, I will differentiate to get velocity. Then I'll differentiate to get acceleration. I'll integrate acceleration to get velocity. I'll integrate velocity to get displacement. So they say that out the velocity. So this is my velocity here. So if I have velocity and I want displacement, I must go up the ladder, which means I must integrate. So displacement is going to be the integral of velocity with respect to t. So w is equal to the integral of 2t cubed minus t with respect to t. So w is equal to 2t to the power 4 over 4 minus t squared over 2. I can't use k, I'll use plus c, but c is a constant. Remember, t is time, w is displacement. When t is 3, the displacement is 25. When t is equal to 3, w is equal to 25. So I'll get 25 is equal to 3 to the power 4 over 2. I just simplify the fraction. Minus 3 to the power 2 over 2 plus c. 3 to the power 4 over 2, take away 3 to the power 2 over 2. 3 to the power 4 divided by 2. 3 to the power 4. Alright, so divided by 2 is 40.5. Take away, that is 9 on 2. I get 36. When I move the 36 across, it becomes minus 36. So 25 minus 36 is equal to C. I like to double check. So 25 take away 36 is equal to minus 11. So C is equal to minus 11. So therefore, W is equal to T to the power 4 over 2 minus T squared over 2 minus 11. Right, and that's it for number 5. In a lower sixth form, there are 43 students who are studying either statistics or physics, or both statistics and physics. 28 study statistics. All right, so questions like this, a Venn diagram is your best friend. Let me have a statistics here. Let me have a physics here. It don't have to be perfect circles, right? So they say that 28 study statistics and 19 study physics. So I'm going to let this be X. If that is X, the people who study statistics is going to be 28, take away that X. And for physics, it's going to be 19, take away X. If a student is selected at random, determine the probability that he is studying both statistics and physics. So we had to calculate X, basically. So we know that our 43 students comprises of the universal set. So if I add up each individual part, I'm going to have 43 is equal to 28 minus X plus 19 minus X. 43 minus 28 minus 19 minus 4 is equal to minus X. Minus X plus X is 0. And I get X is equal to 4. So if X is equal to 4, my Venn diagram will be nice. If a student is selected at random, determine the probability that he or she is studying both statistics and physics. So the probability that the student studies both statistics and physics, yes, you had to write it out, right? Is going to be equal to 4 out of the 43. Physics only, the probability that a student studies physics only, that is 19 minus X, which is 15. 15 over 43. Easy peasy. A tetrahedral dice has 4 faces. 2 fair tetrahedral dice, one red and one blue, have faces numbered 0, 1, 2, 3 respectively. The dice are rolled and the numbers face down on the dice are recorded. R is the score on the red, B is the score on the blue. Compute the probability that R is 3 and B is 0. Draw a sample space diagram here, right? Just like how we have this one here. So we join a sample space diagram. So we're going to have outcomes going to be 0, 1, 2, and 3. And the next set of outcomes going to be 0, 1, 2, and 3. So let me say that I'm going to color code it, right? This going to be my red dice. This going to be my blue dice. So my outcomes going to be 0, 0, 0 on the first red. Okay. Lord, I'll go have to keep changing colors. All right, so the first number will represent the blue. The second number will represent the red. So 0, 0, blue, red. 1, 0, 2, 0, and 3, 0. I want to know the probability that red is 3 and blue is 0. So here I go have 3, 3. Over here could be 3, 0. So they're the probability I'm looking for, right? 3, 1. I lie. Oops. 1, 3, 0, 3. So this one here, blue is 0 and red is 3. So yeah, still. So I'll have 1, 3, 2, 3, 3, 3. All right, so the probability that a red is 3. Oh no, this is easy, man. I didn't have to go into a sample space. The probability that the red is 3 and means multiply. The probability that I get a red, the red dice is 3 going to be 1 out of. Yeah, this could be a quarter multiplied by a quarter. It's going to be 1/16. Yeah, probability of red by probability of blue. Cool. So we could say that out. Probability that red is 3 multiplied by the probability that blue is 0 is equal to this. All right, so I don't have to go into the sample space diagram. A random variable t is multiplied by b. A random variable t is r multiplied by b. Complete the table below. All right, so red by blue. 0, 0, 0. 1 by 0, 0, 1, 3, 0, 0. 2 by 1 is 2, 3 by 1 is 3. 2 twos are 4, 3 twos are 6, 6, 3 twos are 9. Just completed. Okay. Okay. All right. The table below shows the probability of each possible value of t. Calculate the values of a, b, and c. So, if the probability that t is equal to 0 is a from a sample space, how much times t is going to be equal to 0? 1, 2, 3, 4, 5, 6, 7 out of the 1, 2, 3, 4, 7 out of 16. So A is equal to 7 out of 16. B is equal to, how much times did we get a 3 in the table? 1, 2 out of 16, which is 1 out of 8. How much times did we get a 4 in the table? Once, 1 out of 16. And if you add up all of these things here, you're supposed to get 1. So you can check it over and see if you get 1. Let's check it over and see. 7 out of 16 plus 1, 8 plus another 1, 8 plus 1 out of 16 plus another 1, 8 plus 1 out of 16. 15 out of 16. We're missing something. I have 1, 2, 3 8s. And I have 7, 8, 9, 10. 10 out of 16 plus 3 8s. Yeah, good. I missed out a value. I get 1. Determine the median and quartiles for the data. So we could cancel first with last. All right. So you could cheat a little bit here now. If we go cancel, let me cancel the first 5 with the last 5, and then we go with singles now. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We could cancel our next 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let me cancel 2 by 2. 1, 2, 1, 2. 1, 2, 1, 2. Let me cancel 1 by 1 now. First with last, 41. So Q2 is 41. Q1 is going to be the middle of the first set of values. So I'm going to encircle this here, and I'm not counting that. And I'm going to go over first with last again. Now, when I'm doing this on the paper, write out the numbers and do it. So I have the ability to rub off. I mean, all I have the ability to rub off as well, but don't rub it off. Leave your working there. I'll just use a different color. I'll cancel first two with last two, first two with last two. Yeah, I could go first two with last two again. And then I go 1, 1, first with last. 33 is going to be my Q1. My Q3 is going to be same thing I'm gonna do for the second half of the data, right? First two with last two, first two with last two, first two with last two, and I go single now. 9 and 52. Box and whisker is sure. Yep. Now for your box and whisker, you have to draw it to scale. Alright? So when you're drawing a box and whisker to scale, creating your scale, and you can't just go and say, well, you know, this is my box. This is the box. And these are the whiskers. And then you just decide to put in values helter-skelter. It must be to scale. So I will try to draw it to scale as best as I can. So my box and whisker will start with my 10 as my leftmost value. Then I'll go 10 will stem straight to my Q1, which is 33. So I'll draw my box here. From my box, I'll know where to put my median. So this is going to be 33. So the distance between here and here is 23. The distance between Q1 and Q2 is less than 23. So I'm going to make this distance here less than 23. Right? So my one is not the scale, but it is an accurate representation. This is going to be 41. So from 33 to 41, that is what? 33 and 9 is 33 and 7. So 33 and 9, 33 and 8, sorry. I lie. 8? Yeah, 8. 33 and 8 going to be 41. So the distance between here and here is 8. Now the distance between 41 and 52 going to be 11. So I can make this a little smaller, but it had to be bigger. Remember, this distance here is 8. It had to be a little bigger than 8, but still smaller than this side here. And that's where all the scale go come into play. This could be 52. And my leftmost value is 64, which is about what? 12 away? 64. Once you draw this to scale, everything will line up properly. So what you're doing is you go take your ruler on the bottom and you're creating your scale. So which part 10 is? 11, 12, 13. Use probably... You could use a centimeter to represent 1 millimeter is 1. Yeah, 1 millimeter is 1. Or 2 millimeters is 1. You could use that. Alright? I'll probably draw a scale next class. I'll pull out the ruler and draw a scale. Do I have a ruler here? I have a ruler. But I don't know how to use this ruler. I don't know. Wait. Oh, okay. I learn how to use ruler. But alright, so let me see how we can work this out, right? Can I put markings on the ruler? I never used the ruler in this thing before. Alright, so basically what I'm saying is this, right? Let me just say, right? This is 10. This one, oh god, can write good. This is 10. This could be 20, 30, 40, 50, 60, 70. And you figure out every millimeter now will be 1. And you fill out, you line up your boxes, your Q1, your Q2, your Q3, your 2 outmost values with those scaled numbers on your ruler, and you could be good to go. Right, and that's it for 2018 specimen paper.